This is a video on how we debug our own code. So what does that mean by debug? Debug means getting rid of bugs. So these could be syntactical error, could be logical error, or it could be compilation errors in multiple instances where it is not easy, right, for developers to find out what they are before compiling and running the code. You can use a debugging tool or steps or recommendations as best practices to move forward with getting rid of bugs. So this is the reason why we debug, right? How you validate and check your code. So there's a couple of levels of debugs, and let's go through some of the examples that we have. The first one is the code level debugging. And of course, as you see, there's a lot of cout, printf, where developers would do. And this actually makes your code a lot more bloated than is necessary, where lots of cout and these manual printfs strewn all over the places in your code, making it look not very professional. So this is also where as a best practices, we will mandate developers remove all of this unnecessary cout and printf, and leaving the standard loggings to a file or some sort of remote server, and never in your code write these debug statements that don't mean anything in productions, right? So that's the code level debug. There's another step. This is number one. This is number two alternative is use IDE. So IDE these days, integrated development environments come with what's called debugging tool, which is a software or plugin that is on top of your IDE. Depending on the use of your IDE, you could have Eclipse, you could have code blocks, you can have Qt, right? There's a whole bunch of them. There are various different debuggers that you can use, but generally these debuggers, they come complete with certain set of instructions that look very, very universal across different IDEs. So this is one example of, this is a screenshot. Oh, this goes back to the basics. So this is an example of the manual, right? Cout we're talking about, where developers, they'll just write stuff like this. My recommendation is, yes, you can do that. So at some point when you decide to deploy this code, get rid of these things, right? Otherwise, they'll just clutter your code, making it very hard to inspect or maintain. So some of the debugging tools, as I alluded to earlier, depends on your IDE. There's a code block, there's Visual Studio, there's Qt Creator, Eclipse. You can actually go through, some of those are YouTubes. They're still pretty current, in my opinion. You can see how these debugging tools are used. So I won't get into the details of it, but just to illustrate some of the functions and that you will see inside a typical debugging tool. Now, depends on your IDEs. Now, they may be naming this differently. Sometimes they have this stop debugging as stop, right? There's no debugging here. In this case, this is actually for breakpoint. So in some IDs, they should call it breakpoint. So this allows you to kind of place artificial stopping points where the debug will actually land on and stop the execution in general, to allow you to kind of peek into the runtime system at that moment in time, right? So there's restart, right? Restart, we know, to wherever you pause, right? Something, there's a restart. This stop and stop are the two stop gaps, right? That completely start from scratch or stop completely the entire debugging actions. There's also, at any moment in time, let's say if you're at, this is the line, right, 9 right here, and your breakpoint's right here, your entire execution basically stops right then, right? So this is where the execution stops. And at this point, you can decide to step into, step over, step out. Step into means that, let's say this is a function call, right? Function call. And this function call has its the entire function definition somewhere. Step into means that at this moment in time, let's step into the function and check every single one of these lines one at a time. That's step into, right? You're stepping into its nested, right, function calls. There's also step over. Step over means don't worry about this line. Let's just step over into the next line, right? Step out means, let's say if you're here and you want to step out, meaning you want to exit this entire function loop altogether. you can actually just go back, right, to the previous calling function that leads to this function call to begin with. So there's into, over, out. Again, these are some very useful methods methods that you can call on to get to places. Let's talk about assert. So in C and C++ programming language, assert is a macro, which is basically a function that is designed to be used like a function, right? Assert checks the value of an expression, right? So we talked about an expression. The expression could be a Boolean, right? Specifically evaluating to either a true or false, right? So if you have a Boolean expression inside of it, and you said inside of this assert, right? This expression evaluates true or false. So if the expression is true, right, which means the expression evaluates to a 1, right? So 1 is true, right? And the other alternative is 0, which is false. So if this is true, then what's assert going to do is the assert macro writes a message to, right? Actually, no, in that case, the assert would bypass, would let the execution continue. But however, if the Boolean expression evaluates to a false, right, in this case, false, then what happens is the assert macro, right, or function writes a message to the standard error log, right, and terminates the program by calling abort. So there is a abort, right, that gets called. If your assertion is incorrect and you don't want your code to continue to run, you want to simply just stop, right, stop the whole thing altogether. So this is useful frequently in development unit testing, sometimes in continuous integration as well, because this is where you don't have the entire code bases in production, but you want to know, hey, there is a really, really urgent error that is being manifested in this situation, so you want to stop the whole thing. So you can have the assertion, this is what we call assertions, strewn in some of your code to ensure that there is a some sort of hard stop that happens. This is an example of assert. So let's say if you have a function that you're writing, and this function is called reverse integer, and then you have your parameters set as -1, and you know reversing this integer equals -1. This should be true, right? Reversing -1 gives you -1. So if this is true, you already know it's true, assertion is true. But if, say, your reverse int function implementation has a bug in it, such that reversing -1 doesn't give you -1, then in that case, that's not okay. Then you want to have your assertion basically stop the basically terminates the program. Let's say if you have a whole bunch of assert there, terminating a program allows the error log to be written to the console. It specifically will tell you the line number, okay, of this assertion. This gives you an indication as to, whoa, this is where this error happens. So, so the program doesn't continue on. So this is another useful way of basically pinpointing, okay, pinpointing the specific location, the exact location of this fault. So you can use that. In C, C++, if you were to use assertion, you want to include, so this is in C as well. You want to use include assert.h. That will give you this assert function macro to make use of. This is an example of an assert. I pulled this out of some production code. So this is the assertion that is written in C, and this is in platform dependent. So some of the platform may have this implemented in a different way. So you can see here, there is a buffer, right? And this buffer actually allows for all of these error messages to to go right in there, and then you print it, right? The abort buff actually prints the entire thing. This entire thing actually gets printed to the console. So when something X, right? So when this X is a 0, not, right? Assert, right? This means when you have not false, meaning true, then this is the error case, right? This error case gets printed and aborts the entire your code at runtime. So your code will completely exit at this location, and it also gives you the file name and the line number when this fault occurs entirely to the console. So this is a very useful macro, and this is how assert is implemented in C and C++. So you can literally write assert, right? ERT, and then with your whatever conditional Boolean expressions you will have, make sure there's a semicolon because you want this to be a statement or a function call rather. You can have this type of template sitting inside your code, to help with your development. So this is a general overview of different ways where you can debug.